So today I'm going to talk about SaaS. And we all love SaaS products, right? We all love cloud products. We use them all the time. There's a cool new service I've just discovered. Just put my username and password, start using it. Works like magic, right? Have you developed ever a SaaS product or been part of the development of a SaaS product? Cool, so most of the audience. So to you guys, this probably looks like reality of that internal SaaS product, right? You have this spaghetti code integrating various external APIs, doing some internal magic that implement various weird workflows and whatnot. And usually, you end up with sort of this kind of situation where you have tons of things integrated together, and to the outside world, it looks like magical SaaS working. So today I'm going to talk about how these tools are built and what are the general principles of building a SaaS product and what to consider and think of when designing one if you're thinking about building your own product and your boss is sitting next to you. So make it look like you're taking personal notes for work. So my name is Berezin. I'm the founder of a company called JovianX. We basically have a product that helps building SaaS products. And some of what I'm going to talk about today is sharing the things we've learned while working our own product and while helping customers building SaaS. So let's see what it actually means to build a SaaS product or to build a cloud product. So usually start off by this great idea. I'm doing this cool cyber thing. I'm securing endpoints, doing some cool magic in Kubernetes or whatnot. And I have my core business logic that I think of implementing. All right, cool. So I have my main principle being implemented. Is that a SaaS product? Not really, right? I'm just implementing some core thing. So the first thing you need to think of when building a SaaS product is to make sure that this piece of software is available on demand, right? This is the major shift we've been through from on-premise software where the user has to install the software, deploy it, configure it, maintain it, blah, 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 do all the back office management stuff in order to make it happen, where today we just put our username and password and boom, we have magical access to the product itself. And to make that work, there are multiple things we need to consider when doing the implementation. So the first is doing the automation around the cloud resources, right? We have AWS, which is amazing. We have the GCP, which is amazing. Azure, all of them have APIs. And we need to start considering how do we automate all the process around these APIs, right? I have tons of new users coming, signing up to my service. So I need to make sure I have automatic resource provisioning. I know to build a resilient infrastructure, right? Most of it includes automation around these processes. Authentication. So I need to make sure that all my users are authenticated and authorized to use the service based on their permissions. Multitenancy. I'm going to dive into that in a bit. DNS management, SSL certificate management, emails, automating all the email sending processes. So all of these are usually part of making the software available on demand. The second part that I need to think about is how do I maintain and manage that service and do my own back office management. And that, as no surprise, also includes tons of services I need to think about. So user management, obviously I have tons of users as part of, and tons of accounts as part of my software. Upgrade delivery. So I'm pushing new versions, right? I have 10,000 customers in multiple tenants, multiple regions. How do I automate the delivery of my software? Not just the integration and testing of my software, but the delivery to the customer, to the production environment itself. Monitoring, right? So something goes wrong. Something always goes wrong. If something can go wrong, it will go wrong. And I need to make sure that I'm able to catch that in time and fix the situation. I need to collect logs. I need to send alerts to the right people at the right time, right? If, for example, I have an on-call person at a certain time zone, I need to make sure I'm sending it to the right message. But the last part that we usually, as technical people, tend to forget is that SaaS is also a business, right? And the major paradigm shift that we're going through, or we went through, was that we have a recurring subscription-based business, and there are tons of things we need to take care of when building that as well. So a user subscribes is not just means not only provisioning the resources, but also make sure he subscribes to the right billing plan. I make sure that I can manage and maintain these billing plans, and my product management team can update them on demand based on things that are happening on the market. I have a new competitor that suddenly lowered his prices, right? I need to be able, or my product team needs to be able to control that on demand. And there are tons of things I need to figure out and make sure, when I'm building them, make sure that they are dynamic enough and not directly tied to the core product that I am delivering. And I mentioned earlier the topic of multi-tenancy. So all of us think, hey, multi-tenant product, what does it actually mean? Like, I have multiple rows in my database and done, right? So there are multiple things, or there are several things I need to consider when I'm building a multi-tenant product. And I need to understand, what am I optimizing for? Am I a B2B product? And what's most important thing, and the most important thing to me is isolation of the data between tenants' accounts? Or is it that I'm optimizing for scale? For example, I'm building a B2C product and I'm expecting millions of users. Obviously, I won't be able to spin up a VM or a container per end user, right? So I need to optimize for that. So let's talk about the various models of implementing a multi-tenancy model. So we usually start off by something very simple. We have the database, we have the business logic, a nice shiny UI that allows my user to click the various buttons and toggles, and there's me, a single nice tenant, a single nice user in the platform. So what does it actually mean to add another user to the platform and start implementing this multi-tenancy model? So the most common way to think about this scenario in B2C products, it's very common in B2C, is implementing multi-tenancy at the application layer. Meaning my business logic always knows the context and the account that I'm working on. And this means that my developers have to be very careful when doing various operations. If, for example, I have an asynchronous action, I always need to make sure that these kinds of operations are in the context of the account, and they need to be very careful about implementing the calls to the databases and showing the right user the right type of data. And obviously, this is optimized towards density and lower costs, but also there's a low level of isolation between the data. For example, if I'm a cyber tool and my developer did a mistake and he can see now data from another account, this is a major no-no, right? For a cyber company, this is a major no-no, where usually B2B products are optimizing towards the isolation. So if you look at, the optimization levels, we can optimize either towards density, where we have lower costs and we expect a lot of more users, but we have to give up the isolation, or we optimize towards isolation, where we usually need to pay a little bit more for resources, for cloud resources, in order to implement isolated environments. Now, also, it's not black and white. We have different levels of isolation. So what I mentioned earlier was the targeted was optimized towards the high density scenarios. Another scenario is the multi-instance multi-tenancy. So I can spin up the whole stack of my software yet another time per customer, right? So my cloud resources allow me to automate all of this scenario, and I can spin up, I can have a fully separated environment, and I'm highly optimized toward isolation. There's no chance, like, they're completely in the different instances of infrastructure. So there's no way for one account to get data from another account. And that's obviously optimized toward the isolation of the environment. And the cool thing about containers in Cloud-Native, that it sort of allows me to cheat a little bit and not spin up full-blown VMs, which are kind of expensive, per account, rather to spin up containers on a container cluster. So I do have a little more optimized scenario towards density, and I'm not paying as much as I would per VM, but I'm still having a rather good level of isolation of data of my customers' accounts. And also there are sort of the middle ground areas where I can have a multiple database per account. So my software tier, my business logic still needs to be aware of the context in which it runs, but the data is separated. For example, I'm a healthcare company, right? And when a customer leaves, part of HIPAA compliance I have to make sure I'm part of, I need to make sure that I'm deleting all the data, or GDPR, for example. So a very easy way to implement that would be to have a separate database, or to have a separate schema. So I'm not really having a separate full-blown instance of the database. Rather, I have just yet another replication of the schema per account. So I'm still having a rather good level of isolation, but I'm not spending that much amount of resources in order to onboard a new customer. And that obviously a little bit more optimized towards the density, but still allows me a good level of isolation. Now, taking this approach, and obviously any of the approaches that I mentioned earlier, there's another model, which we see happening also quite often. So there's the hybrid model, where it allows me to isolate resources between accounts, but still have shared backend services. For example, I'm having my business logic doing some magic with cybersecurity, but I want to do some big data analytics based on that data. So I can still send the data to my backend services that are shared across accounts, but from the application level, have them fully separated, and I can decide which components of my software I can have shared and which should be completely isolated. So this kind of gives us a rich set of scenarios for implementing a multi-tenancy. And the next topic I want to talk about is the use of cloud services. So as I mentioned earlier, this spaghetti code that we use, most of these components are actually available as cloud services, right? I have a database as a service. I have Stripe, which is an amazing API to do billing. I have products such as Recurly. We have Datadog, Logs.io. We have tons of services that we use. And usually we have the main business logic of our own application that is doing the integration and the consumption of these services to bring up a cloud service. So a good thing to think about is, where does my business logic run? Like traditionally, I would have run it on VMs. But also now I have much more choice. So I can run it on containers, which is cool, allows me to do more density. I can run it as functions as a service, right? We have Lambda, we have OpenFast, we have Knative as an example, which are a set of tools that allow me to run functions. And the thing that I think that should be more discussed is, how do I optimize and which should I choose for each scenario? Because there's this whole hype of serverless, right? But people don't consider the fact that at some point of scale, it becomes much more expensive than running full-blown VMs or even hardware, which is kind of crazy. So we need to sort of prep the use case and consider the costs and the implications of using a specific technology for a specific solution. If, for example, you have an app, a very simple app, you have tens or hundreds or even thousands of users, hey, maybe functionless is amazing for you, right? You have few calls, you pay based on call or based on runtime of that call, and the total costs of that solution would be much cheaper than running VMs or containers or nodes for Kubernetes managed service, for example. So like you can pick and choose, and also there's this new trend of metal as a service or hardware as a service, where you can have your own cloud service giving you the whole VM, the whole server, the whole physical server just for yourself. If you are if you have a very heavy load if your application is very consuming a lot of load, so you can also have that as part of your tool set. And again, like, very important to understand where you go and what type of workload will you have and optimized for. Another topic that is very interesting is how do you choose between managed services, and which of them would you build your own, right? You can use Atlas, a great cloud product by Mongo, or you can just deploy Mongo in your own managed Kubernetes cluster and manage it by yourself. So few things to think about when choosing which cloud services you deploy on your own and which you manage is how much level of control would you like to have. Also the costs. Like at some points, at some scenarios, the cloud service might be more expensive for you than to hire the team that operates that. But also sometimes you would like to hand the control to the service provider and not have your own people focus on that. So two things to keep in mind when kind of considering that. First is this part of software, is it my core? Is that the main thing I'm doing? Or should I just give control of that to another provider? And the second is, like, there's the known saying is the only constant in life is change. And how do I prep myself for that change? And which parts of my software should I be able to adapt on change, and which parts should I just assume that they're going to keep running the same? And I'm going to end on another, on one last point that I personally find very interesting is open source SaaS. So we're all here because of open source and open source software, right? Everyone can see the source code of any software, use it, consume it. But the way that cloud products are developed are entirely different. Like, we never see the source code. We never have control over the product. We can never contribute it back to it. I'm a big fan of YouTube. I would like to add a cool button, and it happens to be that most users of that service would like to add that button as well. So theoretically, in open source, there would have been just a pull request that contributed that feature. The community would have accepted it. Cool. In SaaS, it's much more difficult because you cannot give, like, the way cloud products are built today, you cannot give access to the product itself. So it's quite impossible in most products. But I think this paradigm is shifting a little bit. And if we all use external services and develop our own core separately and use these services, basically we have a good level of separation between the infrastructure that runs our SaaS solution and the core of what we do. And this kind of allows us to have this scenario where the core of what we do is open source, and we do allow our users to participate as part of the development of that core while maintaining the security level we have to have in SaaS and cloud solutions. And we do see quite a few examples of that. So all the managed cloud services in the recent years that we've seen, like MongoDB have a product that is called Atlas, right? We have MongoDB as a service. I can contribute to MongoDB. I can contribute a new function. I can improve that product. We have Scylla, just a local representation. ScyllaDB, also a great product. They've announced their SaaS product. So it is an open source solution. And we can contribute to it, but it's still a full-blown, full-fledged cloud product. And I think we're going to see more of that. And we have, as a community, we'll have more control over the cloud services that we are consuming. So exciting times ahead of us. Thank you.